today I've decided that I want to take on a few case studies because होता ये है कि lot of people have questions कि सर आप economists जितने हैं आप लोग करते क्या है? What exactly do you do? तो the question is a valid question. Mostly economists study data and they study the implications of data. So many times what happens is that if you have a project, whatever project you have, it doesn't matter what sort of a project you have. If you have a project, it will involve resources. And then the application of the resources in terms of what you're going to do with the resources, how are you going to apply those resources, what will you produce, how will you produce it, where will you produce it, how will it be sold, what will be the implications of all the things, all those activities that you will be doing. These essentially are what is studied in economics. So very quickly, if you have to define economics, what is it? It is the science of choices. ये word कभी मत भूलना. It is the science of choices. So what are choices? The choices are what material do I use? Where do I use this material? Which will be my market? How will I sell whatever is the ready product for the market? What will be the implication of the decision that I am making? These choices are generally what are studied. But many times we must always remember that choices also have trade-offs. एक choice करोगे आप तो दूसरा choice आप नहीं कर सकते. For instance, if you decide to build a road through a certain area, you cannot then build a residential complex on the area that was reserved for the road because you have made the choice of building a road through the area. So these choices always have trade-offs. So some area that you use, let's say for setting up industry, tomorrow you cannot decide to have that same area having a public playground because you've already decided to have industry over there in that area. So when you make this choice of having industry in a particular area, what will be its implications? When you decide in having a road in a particular area, what will be its implications? These are the choices and the trade-offs. Always remember trade-offs. ये भी एक key word है. The study of the trade-offs. These are all the part and parcel of economics. And how do economics calculate trade-offs? Economics calculate trade-offs by using mathematics and especially mathematical formulae, equations, and tools such as, for instance, regression. What do regressions do? Regressions measure the trade-off against each other. Measure these trade-offs. Measure the impact of these choices. Measure, ये keyword है. This is what we do in economics. So today, for instance, I have taken my studies generally are in resource complexity economics. I have taken two topics that I will cover today with you. And the two topics that I will cover today with you is the implication of a project, let us say, in a riverbed where the government perhaps is interested in beautification of the riverbed, and the implication of a project where the government, for instance, intends to take a road. It intends to build a new road. Generally, when you beautify a riverbed or some such thing, the purpose is so that it becomes a recreational area for a lot of people who are normally living in the surroundings, so to speak. So if you are passing through a city and you realize, oh, there is a riverfront which needs development, you work towards ensuring that you have a beautification plan or some sort of thing such as that, which is organized. So I will give you the analysis that I have made for two such projects. One project of a road which has passed over a hill, so it is supposed to be like a brand new road, and generally you create a brand new road so that you are able to ease the problem of traffic and the problems of let us say congestion and so on. So let's look at some data. We have done some data analysis. Let me show you some data so that we can all start to interpret what is the data. So this is a total length, let's say, of 373.5 kilometers. The length of this so-called river. And the length from the origin of this river, let us say, is about 59 odd kilometers, and the length of this river, let's say, is about, again, almost 44 plus 12, you can say about 56 odd kilometers. So the length is more or less similar. Then the length of this third lever, all right, is again about 16 odd kilometers. So how will this actually look? Let me try and see if I can give you an illustration. So you have a dam. Let's call the dam the Pauna Dam. And then the length, like we know, is about 56 odd kilometers. Then you have another dam, which call it the Mulshi Dam. The name of this river is Pauna. And then this Mulchi Dam again has similar length. River of this the name of this river is Mula. Yeah. So they travel 56 kilometers to here. And then we have another dam which is called the Khadakwasla Dam. And the length of this river which reaches here is approximately 15 kilometers. They meet here in what is known as a Sangam in general Indian thought parlance. And then this river travels through the city for what distance? Let's look at the distance. Approximately 51 plus 19, 242 odd kilometers. Mulla Mutha. That's what it's saying. It gets called Mulla Mutha. (242 kilometers), and at a certain place called Khamgaon, another river called Ghod comes and joins this, and that is why the river which flows further from here is called Bhima until it hits a dam called Ujjani, and this entire riverine basin, so to speak, is about 373 kilometers. Why is this important? This is important because we know the topo sheet or the dimension of the circumstance that we are studying. This is a part of the economics. If you were looking at it from the perspective of a company, you would consider this as your universe of study. This is as the universe of your topic or so on. Now, I'll start explaining the dimensions of the problem to you. This city, Pune, generates about 1,000 million liters per day of sewage. Okay? This is the data that is observed as well as calculated. This 1,000 million liters per day of sewage, out of this, about 250 million liters per day is treated. So there is a municipal corporation, and the municipal corporation under the sewage treatment plants, etc., that they have, treat 250 million liters per day of sewage. And guess what they do with the treated water? You guessed it right, they pour it into the river. Other than the 250 million liters per day, you also have a balance 750 to 800 liters per day, million liters per day of sewage, which directly finds its way into the river through various inlets along this 373 kilometers that we have. So I am cutting these places off to demonstrate the sewage inlets that flow into this river. Do we have a count of the sewage inlets? No. What should be the correct thing for an economist to do? Should be to study all the sewage inlets, GPS tag them, photograph them, figure out the flow rate from each sewage inlet and plug them, as in block them. Why plug them? So that you do not pollute the river. Right? That is a simple project. That is what economists should do. That is what government agencies should do. That is what research scholars should do. That is how you generally deal with any problem, at least from the economics perspective. But what has happened is, very conveniently, like we have all government agencies doing what they do, they have figured out that perhaps that is what we don't need to do. What we need to do is do a beautification project only in this area. This area comprises maybe 44 kilometers. And in this beautification project, they have already budgeted 5,000 crores. That is the amount they have budgeted for this beautification project. And what will they do in 5,000 crores? They will pour close to 2.5 or maybe a little more crore tons of concrete into this river basin, so that they can cover up for it looking as bad and dirty as it does. So we will not figure out the root cause of the problem. We won't go there. We will not fund economists for their study, or we won't engage any other consultants, or we won't try to find out how we can deal with the root cause of the problem. What we will do is we will spend 5,000 crore rupees on pouring concrete into this section of the river so that we can beautify it. Now, this is what they call a classic case of not listening to the educated. But that is okay. Things like this keep happening in government all the time, and one must always keep an open view or an open mind about this. Now let's look at the implications of pouring in 2.5 crore tons of concrete. The implications are that concrete is a heat sink. And many times what happens is that area in which you will pour concrete, this will become a heat trap, because concrete absorbs heat. And up to what extent does it absorb heat? It absorbs heat up to the extent of 6 degrees centigrade. So if your average temperature over here in this area now, because of all the natural vegetation and whatever else, and maybe it is dirty to look at and whatever, but if your average temperature here is about 30 degrees centigrade, your average temperature will rise and become 36 degrees. And this is an unnecessary increase in temperature when we really don't have the need for this to happen. But well, you will have to pour some concrete in any case. So we will have this happen, and maybe if they get ahead with this project, these are the implications. So let's look at the data again. The data that we have studied. We have the length of the rivers over here, and we have some other data in other places, I guess, but it doesn't calculate the amount of concrete that is going to be poured into this. But if we look at maybe how we calculate how much concrete will actually go in, this is generally what we pick up, economists pick up from tender documents which governments bring to your notice. And then you can see, for example, that this is how they will do whatever work they will do. We will calculate whatever is the cubic meters perhaps of concrete poured in. Then we calculate what will be the rate at which it will be done. And then we will calculate the total carbon emissions. So for instance, in this road project, we have calculated very easily that the emissions, total emissions, is something in the range of, let me see, I think it's more than 100,000 tons, but because we are calculating for steel, you can notice we are calculating for the retaining walls. So there you are. You have a carbon footprint of about 115,484.78 tons. And for the steel, you have a carbon footprint of 8,371.63 tons. This is the work that economists do. This is the work, this is how we are calculating the carbon footprint for the new road. This is the example, for instance, that you need to see so that you understand that it's hard work, it's hard back-breaking work to come up with these calculations and understand exactly what impact it is going to have in terms of carbon tons on the environment or on the particular city that we are talking about, on the city's health. Then if I look at, for instance, that particular area from where the road is going to be going, and I consider that I want to demarcate the area via perhaps a satellite photo, which tells me that this is the catchment area, for instance, along with this wetland. This is the catchment area, for instance, which will catch the rainfall in an open space through which they are proposing to take a road. What exactly will be the rainfall and how much of this catchment area? Because if it's an open area, it simply means that the entire rainfall is going to be absorbed into the ground. So very important to understand that if we are going to be calculating how much rainfall we get in this catchment area, we should know the exact considered area using perhaps a satellite image, and then we pick up the rainfall data from whichever is the Sarkari website, so that they don't have a problem with us saying, boss, you did your own thing. So you take the Sarkari data, it's actually called secondary data in economics in our studies. Then you calculate the rainfall per square meter into whatever is the depth of the rainfall received for that particular period. And then once you decide that once you come to the exact figure of what is the total rainfall you receive over 1 square kilometer, 1 square meter into this total area of square meter, you will come to your numbers, and your number is approximately 901 crore 41 lakh 60,722.3 liters. This is the kind of work, the hard work that economists have to put in to come up with the data that is required for you to understand the impact analysis of taking a road perhaps through this area, or for that matter, pouring concrete into your river. So I hope today I have explained these two case studies in a way in which you understand what is it that economists do, how do they present data, how do they do their research, what is it that we study to create these functions which help you make a decision. Now, right or wrong, whether these things should be done or shouldn't be done, the trade-offs, etc., those are things we haven't calculated yet. But if you ask me personally, I feel there are many other options which we should consider over just doing this kind of perhaps, what I wouldn't want to call it wanton destruction, but perhaps just doing projects just for the hell of doing them. Thank you very much. Bye-bye.